can proceed.
Okay, so I was looking on the assignment, the regression analysis using the same data, the financial data that was provided. I started by importing Pandas, Seaborn, NumPy, and stats models.
Yes.
And then I read the file through allocating it a variable data.
Yeah.
I checked if it was uploaded by using the data.head function.
Yeah.
The same with data.info. I don't know why
Yeah.
I didn't find nulls here on the sales side. Is it supposed to come here?
The cells, no, the null at the space for null is only in the column name and not in the data itself. The
Okay.
space is only on the column name. Like the column name has space. You see where the others start from is like centrally aligned. The name is centrally aligned or rightly aligned. So there is a space for left alignment. You see, others are all left alignment,
Yes.
the column headers. Yeah, so that's where the problem is, and not the data itself. The data itself has no null values.
Okay. So I checked if the data had null values. There's none.
Yes. Yes.
I selected and I created another variable df to include the only data types that have integer and float. So here
Yeah.
that I was taking match because I didn't need the month number, the year,
Yeah.
and also I think the price was neutral.
Mm.
I would have used it. So from here I saw that my plot, my correlation matrix had some analysis that I didn't need, like the month number.
Oh, okay. Let's check. Let's go back there. Go to the top a little bit. Just there. So the DF. Okay. So the way you are subsetting your data, data dot select type include. Then you select that because I see even the header shows that the data collected everything. Because
Yes.
even I think years are also detected as a float and integers. So what you can do here, because that's why everything was being taken. You see, under when you are previewing your data using info,
Yes.
you see there is even here. Just move a little bit at the top. There is here is integer, little bit at the top. There. Here is an integer. You see, that's why it is still coming. Month number is an integer. And all that information is an integer. So what you can do, you can just subset the data and only collect the columns you want to use and not using the data type. So in this case, you could have pulled out your data based on the columns that you want to use. So for you to do that, you can just delete the df is equal to data dot, so delete select data type. So delete the select data type thing, everything, delete everything after select type. Yeah, like that. Yeah, delete that. So there is where now you can delete also the dot. So there is where now you can use the parentheses, the square, yeah. Then put into the quotes the columns you want. So you can put there, you can put into quotes the first quote, you can put the data you want specifically with how it is named in your data set. For example, in this case, do we have units sold? Yeah, we have units sold, comma, and then you reference.
Okay.
Yeah, use double parentheses.
I needed no.
You're just right. You'll add a final a double parenthesis at the end. Yeah, and not a double parenthesis. You'll add one square bracket to close because we have one open, two open here. So there is where now you can. Okay, so you have unit sold. You have gross sales. Add another variable. Add another variable sales. So for sales, what you'll do, you'll leave space in between, leave space before the name sales. That's what I was saying. You leave space, yeah, like that is when it will be able to see if it will be able to be onboarded. And then the profit, you can call the profit. Those some variables here are associated. That means that we might experience multicollinearity because you can compute the independent variables. The condition is usually that we should not be able to calculate one variable from another while they are independent variables. For example, when you are doing regression analysis. Yeah, so like once you have that, you can now run that and you can be able to see which data will you have. No, the top one, yeah, scroll upward. Yes, data is not defined. You have to run everything from the top. Have to run everything from the top because you have opened your. Have to run from run from no.
From here.
Just run from that. Yeah, just run that and run data also. Run the second one. Okay, run also everything until you reach there. Now you see you have your data there.
Yeah. So it's
Data
here.
there, you see. Now
Yes.
you have your cells and everything. Now you can progress with doing the correlation matrix. So you can just run the correlation matrix thing, and everything I think will be fine now when you run the correlation matrix. Just run it.
So it's here. It's here. I've run
it.
Yeah.
Yeah, you see, now everything is fine. Yeah, so that's how you go about it.
Okay.
So you can now proceed with it later. So I think that's where you are experiencing some challenges, and so you have just to check which way is good for you to subset your data. You can subset your data using the including the only data type you want, or you can just select the columns that you want. Sometimes data types may not be that helpful because some data types they may not be of use, so you can just subset your data based on the columns you want to use. Okay. Thank you so much. George, how are you?
I'm great, thank you.
Yeah, we are just Godfrey had was practicing about what we learned last week, and we were just helping him to be able to subset the data correctly so that he can be able to run the regression analysis.
Okay.
So I don't know if you were able to get our session for the previous week, and maybe you found time to go through. Not previous week, this week on Monday. Sorry.
I got the session.
Yes.
Fortunately, I've been so busy, I haven't gotten time to go through it. Yes.
Okay. Yeah, but I think with the practice, you'll be able to reach where we have reached, and in case of any question, we can be able to go through together. Okay. So, I want us to today we are looking at something I may say something fresh, not that fresh, but hope we can see my screen. Can you see my screen?
Yes.
Okay. So today we are learning something interesting in data analysis, which we usually call hypothesis testing. Who has ever heard about hypothesis testing? Godfrey, have you ever heard of it?
Yes. I did some research. I'm still doing some research in university, so I know about hypothesis.
Oh, that's good. That's wonderful. And George?
I've heard of it through research.
Yeah.
Yes.
Okay. Thank you. So today we are doing hypothesis testing. So hypothesis testing is actually about decision making. And the decision making in it has a confusion matrix. It has a confusion matrix in it. Maybe I'll be able to give more detailed explanation about hypothesis testing and confusion matrix using a particular slide that I used to conduct a Microsoft Excel webinar about hypothesis testing. But let's concentrate here. In case we will need more explanation on it, I'll be able to look for the slide and we'll be able to refer and even get more insights about it So hypothesis testing is a crucial aspect of statistics that allows you to make inferences or draw conclusions about population based on the sample data that you have. So in Python, we are going to use libraries like SciPy and the stats model. So depending on where will we need which. So in hypothesis testing, we have some terms. We have, let me just check for the webinar. Let me stop sharing a little bit and check the slide for the webinar for the easier understanding of the terms to all of us. Yeah. So let me just share my screen again, and I'll go specifically to, let me share my screen again. The screen. Yeah, so let me just go specifically to where we need. Yeah, so I'll use this to explain more on hypothesis testing before we go to the notebook. So hypothesis testing, in this case, we have some terms that we need to understand. Hypothesis testing has types of hypothesis. One is null hypothesis. The second one is alternative hypothesis. So the null hypothesis is usually the claim that we usually have about something when we want to make a decision. The alternative hypothesis is that when that claim fails to happen, what will be the second option we have when that claim fails to be true, which we call the null hypothesis, when it fails to be true. And then we have types of tests. So while making a decision about the type of hypothesis, we usually have types of tests. Like, is it does the test rely on one-tailed test or two-tailed test? So what does this mean is that, for example, we want to compare the mean. Okay, let me talk about the mean salary. Let's say maybe we sample out the salary for data analysts, and maybe we have 10 samples of data analysts, and we have their mean, we get their mean, right? And now we have a claim. For example, we are claiming that, this is just an example, we are claiming that the salary for data analysts is, let's say 30,000 Kenya shillings, for example. And we conduct a survey, like a small sample. We take a small sample of data analysts and we collect their salaries and we do the average. And we get that the mean for the 10 is 40,000. So suppose we want to claim that actually 30,000 is not different from 40,000. We want to compare that actually 40 and 30, they are not that different. So that's where now the hypothesis thing comes in. So when we say that the average actually is a sample, and we will use that to generalize the entire population salary on average. So that's where hypothesis testing comes in. So when we say that the average salary for data analysts in Kenya, for example, is 30,000. You see, that is where exactly, so the null hypothesis will be the mean, the true mean is, for example, 30,000. The true mean, that is the mean for the 10 data analysts. And then the hypothesized mean is the 30,000. So we say 40 is equal to 30, or 30 is equal to 40. And then the alternative will be that either the true mean can be less than or can be greater than. So that one is what we call the two-tailed test. Is where now you can have a value. A value can tend to be on the lower side or on the upper side. The value for the salary, because we are estimating it to be equal to 30. So maybe the probability is that it may be less or it may be greater. That is the two-tailed. But for one-tailed, is that our assumption for null hypothesis is that the mean salary for the data analysts in Kenya is greater than 30,000. That means that the alternative will be is either okay, for null hypothesis that is greater than or equal to 30,000. Then the alternative will be the salary is less than the 30,000. That is now the one-tailed test. I think that example, we can be able to understand what is the one-tailed test and what is two-tailed test. Are we together? Are we together with that explanation of one-tailed test and two-tailed test?
Yes, yes.
Yeah, okay, thank you. So from there, now we come to types of errors while making decision in hypothesis testing, which we usually call it we usually reference to it as a confusion matrix. So type 1 error is the error due to the rejection of the null hypothesis when it is true. Type 1 error is the rejection of the null hypothesis when it is true. So for example, we had said that the mean salary for data analysts is 40,000. Okay, is 30,000. That is our claim. But actually, the true average from the sample is 40,000. So suppose we say that they are equal, and yet in real sense they are not equal. So that means that we are rejecting the null hypothesis that they are not equal, and yet they are equal, which we make a type 1 error. And then that gives us our first value in the correlation matrix, in the confusion matrix. We are rejecting the null hypothesis, which we usually note it with the H naught, while it is true. And then the second value in the correlation, in the confusion matrix, is the rejection of the null hypothesis when it is false. So, for example, there is another example that I used that was very interesting. For example, you go to a doctor and okay, maybe you are pregnant, and now you want to test if you're pregnant or not, and we want to use the confusion matrix to just understand that relationship, how that works. So the first case is that for you, you see yourself you're pregnant, but you go to the doctor, and the doctor says that you're not pregnant. That is what we call type 1 error. You see yourself, you just feel that you are that, but in real sense you are not. And the doctor says that you're not. And then type 2 is where you don't have pregnancy, and the doctor also says that you don't have pregnancy. That is a correct decision. The third one, you do not reject when it is true. That means that, for example, you are claiming that you are pregnant, and in real sense you are not pregnant. In real sense, you are not pregnant. So when you fail to reject when it is true, when you fail to reject when it is true that actually you are not pregnant, and actually you are truly not pregnant, that is the correct decision that you can also make. That one is actually the very true decision that we are usually interested in. We are usually interested in making the correct decision. If you're not pregnant, you're not pregnant. And then the type 2 error is whereby we fail to reject the null hypothesis, where the doctor tells you that you are pregnant, and yet in real sense you are not pregnant. That is the type 2 error. I think making statistics more easier to understand is good when we use examples that resonate to our day-to-day activities. So the type 2 error is the error due to acceptance of the null hypothesis when it is false. So both the errors and the possible scenarios are shown in the following table, which is the confusion matrix we've seen. And now here we are explaining the one-sided and the two-sided, the way I was explaining to you colleagues about the types of tests. So we have one-sided test and the two-sided test. So one-sided test, so here it says that if the alternative hypothesis states some direction of difference, then the test is called one-tailed. You see, some direction of difference. So let mu be the population mean, and mu naught is some specific value. Then the H naught, which is the null hypothesis, is that the true mean for the population mean is equal to the specific value. The way we were looking at the case for data analysts. Against, now the alternative hypothesis is what we reference to. So for one-tailed test, we say that either, in this case, we have a direction here. The mean for the hypothesis is less than, for the alternative hypothesis is less than the true. The true mean is less than, the true mean I refer to the population mean is less than the hypothesized mean. Or the true mean is greater than the hypothesized mean. So this is an example of a one-sided test. Now, for you to use this, that means that you must also give direction to your alternative, the null hypothesis. You must give it a direction for you to use this. So they cannot all occur at the same point. This one only occurs at the same point when you are under two-sided test, where you have no direction. Either it can be less or greater. And that's where we use this. For here, we have to specify. If here is less than, that means that this one will be greater than or equal to. If here it is greater than, then this one will be either less than or equal to. So that's how we interpret the terms there. And then we have some things like the level of significance and terms like the test statistic. These are just the calculated values from the sample data that determines whether to reject or to fail to reject the null hypothesis. So we are going to look at the practical part of it. So these are some other terms like the critical value. What is a critical value? This is usually a value that we usually reference to. We compare it with the test statistics that have been computed from the data to check actually if we can reject or fail to reject. And then we are usually also provided with the significant, the level of significance is 5%. In probability, we usually turn it to 0.05. So we compute the probability value for our data and we compare it with the threshold, which is 0.05. So these are the statistical terms that we use to make a decision in hypothesis testing. So in t-test, which one, the one we are going to cover today is a t-test. It is divided into three. We have one sample, two sample independent, and two sample dependent. So in this case, I will explain them and then we will go back to our Python so that we can understand them further while doing the examples. So in t-test, one sample t-test is where, for example, we have the marks for the students. For example, we have scores for the student for a final exam. And we say that the average mean score for the class, we hypothesized value is, let's say, is 75 in a particular subject. Now we want to compare, actually after computing the mean for the exam, now we want to compare it with 75. Is it different or not? That is what we call the one sample t-test. That means that you just have one sample, which is the student's scores, which is in a particular subject, and you want to compare it with an external value, hypothesized value, external value, for example, 75. And then two sample independent is where now we can go into details to determine if male perform better than female. That is where now the independent sample comes in. For example, in the same exam, we want to compare if male are performing better than female. We use the two sample independent t-test. For the two sample dependent is where the same students, we give them an exam before going to the library. And again, after coming from the library, we give them another exam. The same set of students. So we will have two samples, but they are dependent. That's what we call paired t-test. Simplest way of explaining these statistical terms. So the two sample t-test is where dependent is where we can be able to observe. Like for example, I measure my blood pressure before taking a particular drug, and after that I take another test after taking a particular drug to test my blood pressure level, if it has increased or decreased, if there is an effect. If there is an effect, if an effect has occurred on the same subject. So for the independent is where, for example, you can have a particular sample under control. For example, you have 2 people. One person is injected with COVID-19 vaccine. Another person is not injected with COVID-19. And we are maybe measuring their immunity to check if the mean for the person, the immune for the person who was injected with COVID-19 is greater than the immune for the person who was not injected. Now, that is where we have 2 people, 2 different people, 2 independent people, and we are testing if there is a treatment, some treatment, another group gets a treatment, another group does not get a treatment, to check if there is a significant difference. So that's what we are going to look into today in today's session. So maybe I get some reactions on how I have explained those concepts before we look at our analysis. Can I get some reactions? Is it clear before we go to the analysis? Godfrey, at least you said you are also familiar with the hypothesis. How have I explained it? Is it in a way we can understand?
Yeah, it's clear, though I'll have to research more on the paired and the dependent.
Yeah, so for the paired, we have said that paired is like you must have the same person. For example, you, Godfrey, we give you an exam before going to the library, or we give you an exam before viewing a particular video on particular things that we are going to set. Yeah? And then we take your scores. And then after you viewing the video, we give you another test. You, the same person, we give you similar test, not another test, the same test you did before, we give you after. The same way people going to library now, there is an effect to the same subject. That's what we call paired. Now you will have 2 samples, but they are related because they are coming from same subjects. While unpaired, which is the independent, is where you have 2 groups, 2 subjects. So another one undergoes a particular treatment, another one can undergo a different treatment. For example, Jason, and the other one was, I don't know what, there were so many. So you just want to compare the performance of these drugs on different subjects. That's in the medicine field, how we can use the analysis of hypothesis to be able to check if there is some improvement in terms of immunity of patients, and to test new drugs in the market and things like that. So let me go to, I think we'll understand better when I go to the analysis. So let me share my screen, and let me share my screen. Okay. So that's what hypothesis is. So we start with one sample t-test. So one sample t-test is used to determine whether the mean of a single sample is significantly different from known or hypothesized population. Yeah, that's what we have just discussed. So the steps is that we have to state the null hypothesis, state the hypothesis. So state the null hypothesis, maybe the sample mean is equal to the population mean. The alternative hypothesis will be that the sample mean is different from the population mean. That is a straightforward one sample t-test. So you calculate the test statistic, which is usually computed theoretically, but in this case, we are going to compute it using Python. And then we determine the p-value. We are going also to calculate the p-value using Python. And from there now we can be able to reject or fail to reject the null hypothesis based on the values we get. We don't say we accept, we say we fail to reject because in most cases we are usually interested in rejecting the claim. We are usually interested in rejecting the claim. That's why we usually say we fail to reject. So we start by importing NumPy. So in this case, I am not going to get data from outside. So I am going to, the first case, I'm going to use the generic data, sample data. And then from there, we will import data from outside and use the same approach to handle it. So then from there, from SciPy, I am importing stats. From SciPy, I'm importing stats. So sample data, I start by getting the data. I form an array using NumPy. NumPy is the one that we use to create some matrices, handle some array of data, temporary data, like that. We create data, use data sets using NumPy, and then we can convert them in other ways we want using pandas to manipulate the data. So here I have some generic data, and then let me say this data is about, maybe I take how many samples are this? 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 observations. So maybe let me say that these are the height for plants. For example, I have some young plants and I'm measuring their inch. And I want to make a decision if actually on average, I can conclude that their average mean for these plants is 3 inches. So we do that by, this is the hypothesized mean. The population mean, hypothesized mean is this one. The one we are referring to as, you create hypothesized mean. So this is the hypothesized mean. We want to check if actually this mean is actually different from the mean that is already in this data. So to do that, we perform one sample t-test. So for you to perform one sample t-test, this is the t-statistic we are getting from the stats. We are going to take t-statistic variable. We are creating a t-statistic variable. We are creating a p-value variable. So we are getting all these values from the stats model, from the stats from SciPy. And then we are also calling a method in these stats known as t-test underscore one sample. That means that t-test underscore one sample. And then we call our data array we have created. And then we compare it with the population mean. So from there, we just want to print these things together. We could have just printed them one by one, but we are using the f function that can enable us to combine both the variable name and the text. For example, we want to print the variable here. These are the variables, and we want to add another text before the variable. So we use the f to combine both in the closed quotes. Then we can be able to print the output. So let me just paste this code in the chat section. And because this is generic data, we don't need to get the data set from my end. So you can also have it and see what you can be able to see. And we'll proceed by, so maybe, for example, we want now to run this. And actually here is the output already. I already have here an output for that. So maybe we relate to what we have learned with what we have here. So what is our null hypothesis? Let me just create here a new cell down here to explain some more things. So what is our null hypothesis? So our H naught, which is the null hypothesis, is that 3. Let me check if I can perform the descriptive statistics. So pandas, I think I already have pandas around already. So I can just call data dot data dot describe, data dot describe, data dot describe. Sorry, data dot describe. So data dot describe. NumPy has no data. Okay, this is just data frame. Data frame. Let me import pandas here. Put pandas as PD. Though we have already defined our data as an array. We have already defined our data as an array. So maybe let me call the head, of course, head for our data. We already have the data, does not require a head because it's an array. So maybe we can print the data. Let me see if we print the data, how it will appear as an array or what. So you can just check our data. Yeah, our data is actually a list. So this is a NumPy list, so we cannot be able to perform the pandas actions. So, but what we can be able to see here is that we have here the T statistic, but now let me create here the null hypothesis that we wanted to create. So the null hypothesis is here is that 3 mu, let me write mu in words. I don't want to check for the symbol. Mu is equal to mu naught. Mu is equal to mu naught, and h1 is that mu is not equal to mu naught. So what does that mean? Mu naught. So what does that mean? So mu in this case is the mean for the 3 numbers that we have here. The 3 number for the whole data, the 9 data that we have. So that is the mu. And then the mu naught is the population mean that we have here in this case. The population mean. So we are trying to compare if the mean for this data that we have here is different from the mean for the data that we have here in this case. And then from there now, we take the T statistic. This is the computed value, the T statistic computed. We usually compare it with the T table. There's a T table that you can use to check. But now, once you have the P value, you don't need to look for the table stuff. Just use the P value, you compute the P value. After getting the P value, now this value is what we compare with 0.05. So we compare P value with P value. If P value is less than, the value we get here is less than 0.05, we reject the null hypothesis, which will mean that the mean are different. This 3 is different from the mean of this array of data that we have. Or what we can also do, if that is the case, alternative is that we fail to reject. If this p-value is greater than 0.05, we fail to reject. So in this case, what can we say about this? This is just a generic data. We are going to look at the live data, data from a particular data set. This is just a generic data to help us view this array of data in a simpler way. So what can be our decision here? Godfrey, George, Dennis, based on the p-value that we have.
Being that the p-value is greater than 0.05.
Yes.
So we'll take the recommendation you offered up there. We fail to reject.
Yeah, we fail to reject the null hypothesis. That means that actually the mean for the array is not different from the mean that we have, right? The mean we hypothesized, the value 3. Yeah, so that's how we do that as one sample t-test. That is from a generic data. Let's for us to understand it better, let's look at a case study for data that you can import from somewhere else and have your view over the data. So let me just share with you the link for the data. So this is the data set we are going to use, and can be able to use that to understand better. So let's download that data. Let's download that data and we can start. Let's download that data and we can start. Check the comment section. Just confirm that you've downloaded so that I can be able to know the next step.
Yes, I have it.
Okay. George?
Unfortunately, I didn't follow properly.
You have?
I've been a meeting, so I didn't follow quite.
Oh, okay. Okay. We have just shared a link for a data set that we are going to use. So I just want you to click on the link and download the data so that we can be able to import it to Python and use it to understand hypothesis testing for one sample. And we will also use the same data for the 2 sample t-test. So just confirm once you've done that so that we can be able to proceed.
Okay, I got it.
Okay, so we can proceed. Let me share my screen. So we start by, of course, importing pandas, and also from there, because pandas will enable us to get data to import data from our system as either an Excel or a CSV. So in this case, we have Excel data, and you put your location of your data. So I am going to give my data a name known as exam dataset. So it will be exam dataset is equal to pd.read Excel. And then here I put the link where my path for the data, my path from where my data is located. And then from there now I view the first head, the first 5 rows of my data. So I can just view that, just check that my data is working well. I'll just use a particular cell down above here to help me just check if my data is there. Yeah, so that is the sample of the data. So the sample of data is there. My sample of data here, I have data it is code and the exact like codes of the students, and then these are the hours the student took to revise for the exam, and this is the exam score, this is the level of anxiety, and this is the gender of each student. So maybe I can also check the info to check if there is, of course, you have to do some exploratory data analysis to check if your data has missing values. So in this case, my data has no missing values, and maybe I can describe my data. Yeah, let me just describe my data. I will only interpret only variables that are important. So maybe revise, exam, and anxiety. So maybe I change here to round. I round this to 0 decimal points. Zero decimal points. Just in case, let me just put it to 0 so that I don't have a lot of decimal. So to 0 decimal points. So I can see here the minimum. These are the counts. I have 103 observations. The mean for revise is 20. That's hours on average. Exam score average mean is 57. So specifically, we are going to compare this 57 with the hypothesized value. And then the anxiety average is 74. Level of anxiety. And then the standard deviation, how values are deviated away from the center. So this is 18, 26, 17. The minimum values revise is 0, exam is 2, anxiety is 0. And the first quantile, which is 25th percent, is 8, 40, 70. The 50th percent, which is the median, is 15, 60, 79, or the second quantile, another name for that. And then the 75%, which is the third quantile, is we are not interpreting the code because it does not make sense to us to interpret the code. And then it is 24, there's the Q3, 24, 80, and 85. So that is it. So you can do further exploratory data analysis that we cannot be able to do here because we are not here to cover the exploratory part, because we could have done that to just have a view of our data in whole. So from there, we have seen the head of our data. Hope everyone has been able to do that. Godfrey, I think you should share your screen so that we can guide you from your end, because it is better when we also do it on our site. Yeah.
Okay.
Yeah. So I think you can share your screen. Let me stop sharing so that you can share your screen so that we perform one by one. And by that, you can have even a question to ask where you don't get it. So maybe I stop sharing and I let you share. Yeah, we will guide you from your end. Okay. So you have viewed your head of your data. So to just see some first five observations. So to describe your data, to check how your data is, like in terms of minimum value, maximum value, or to check for null values. If data has some missing values, so you can just use the excel_data.info to check that. Yeah, so there is no any missing value in your data. And maybe you can just describe the data, your data. So I think how we can drop the column known as code. So you can subset your data, you call it df. You can call your data df is equal to, and then you take the is equal to excel_data, then you dot. Now you can call put the not the dot, use the square brackets and call the remaining columns. So just copy the remaining columns and paste there, and you put the quotes, the double parentheses. So that it can be easier for us to just work with small data that makes more sense than computing some averages on the code.
Do we need gender?
Put gender as well, because we will use it while computing the other part, down part. We are going to cover also the two-tailed test, so it will require gender. Yeah.
Okay.
Okay, so you can okay, then now you can run your data, your code. So you can just preview the first 5 observations of your data. Okay, so we can now proceed. We can now start. So run the run the describe for the data set you have created. Okay, so that's what we are interpreting from my end, and we are done interpreting it. So we want to go straight to importing other packages. So we imported, I don't know if you already imported SkyPy. From SkyPy, you imported stats. Yeah, you already have it. Okay, we
Yes,
can
I
now
have it.
proceed.
Yeah.
Okay, we can now proceed. So the first thing we want to do, we want to, from the data set that we have, we want to create a variable that we'll use to reference to exam. We want to compare, we want to check if the exam score for this student is different from, let's say, 75, or it's different from 60, the average score. So because we have, from the mean, we can see that the exam has a mean of, mean of 58 or something. Yes. So I want us to compare. We will be comparing with 60, because that makes more sense, and then we can even change the value we will be using to compare. So we will not be using 60 alone. We will also go to another value, so that we have a different way of interpreting. So from there, we create a subset, a new variable known as exam. So just call exam score, a new variable called exam score. So exam score, we are subsetting it from the DF. So it will be DF, the parenthesis, the square brackets. So we are calling the exam, the variable known as exam. So into quotes, we call the exam. Into quotes, call the exam. Yeah. So that is our data. Then we can now proceed into the next cell. Run that to the next cell. So that is the data we are going to use to perform one sample t-test. And we want to compare it with an existing our hypothesized mean. So just type there hypothesized mean, underscore mean is equal to, we say, 60. And we run that. And maybe you can put comments on your code, so that you can know which step, what is it doing. You can just put comment on from exam score, and then the comment on the hypothesized mean. Yeah. So that is the exam data. Is the exam column. Just call it the exam column. Yeah, not the mean, because its mean we already have it at the top. Yeah, exam column, which we are now going to use. Okay, then the next one is hypothesized mean. So this is the null hypothesis, null value. The null hypothesized value. That is the null hypothesized value. It's the null hypothesized value. Like we are assuming that the average score for the exam is 60, and then we want to compare if 60 is different from 58 something. So from there, once we have done that, we now proceed to performing the one sample t-test. So perform one sample t-test as your comment. Perform one sample t-test. So from there, we define t underscore start. T underscore start, that is the t statistic. So we call it t underscore start, comma, p value. You see in Python, you can name variable different variables at the same time, underscore p value. So we are defining variables there. Then we say equal to, and then now we say equal to, and then now we proceed to now calling the stats.ttest, stats.ttest underscore one sample, underscore one sample. Then we open the parentheses. We open the parentheses, the curly, that one. And then now we call the data for the exam score. The data we reference to the exam score data. So the variable we created, the exam score variable. That is the data that we created that we want to compare that data, comma, and then now we call the hypothesized mean. So you call the hypothesized mean. So Python is going to compute for you this, and you can be able to get the values. So once you have that, you can now print, and down there now you can print the t-test and print the p value. Print t-test, print the variable, the t-stat, the t-statistic. Yeah, the variable we defined, t-statistic, and also the next one down there, you print the p-value. Print p-value. So you can run that. So you see, when you run it that way, you may not be able to know which one was the p-value and which one is the t-test. So you can just give additional using the f function. So say f into quotes. So type there, this is the, maybe just type there t-test. T-test, capital T. T statistic, not t-test, t statistic. No underscore, just type the normal text, t statistic. T statistics or t stat the way you choose it, and then you leave space in between the, leave space. So use the curly brackets, the curly brackets to close the variables, to close and open the variables. That is like shift what? Yeah, shift your normal, those braces. Yes. Close that variable again, and then you can also now finally close the double quotes. Now close the double quote. Close the double quote. Close the double quote for the first print. Yeah, then now you can do the same. You can now do the same for the p-value. Okay. Now you can run again.
Okay.
Okay, now at least there we make more sense than the other one, because we did not have the explanation for what is this and what is this. So we can see that we have the t-test, the t-statistic value, which is computed. So that value is negative. So we usually take the absolute and compare with the t-critical, because you remember when you were defining the terms, we had something like T critical. So this T statistic value is the one we usually compare with the T critical value, which is usually sometimes generated. Some of the softwares do generate by default generate the T critical so that you can compare. Like Excel you can just compare directly from there. But because we have the P value there, that value is the value that we compare with. That value is the value that we compare with the 0.05. So what can we say? What can we say from this, Godfrey? What can we say from this? What can we say from this? What can we say? Hey, what decision can we have? Because we had 60 and we have 58 point something. So we said that p-value, we compare p-value with the 0.05. So when p-value is less than 0.05, we reject the null hypothesis. The null hypothesis is that 60 is equal to 58.57. If p-value is greater than, it's 56. Yes, it's 56. I see, 56.57. So we are comparing that value with 60. So in statistics, we don't look at numbers and say that 56 is different from 60. No. We make a decision based on some confidence, some level of confidence. So at 95%. So in this case, our p-value is greater than 0.05. That means that we will fail to reject. So this means that actually 60 is not, the hypothesis 60 mean is not different from 56.57. So suppose you change your hypothesis mean to 70. Change your hypothesis mean to 70. And also run the test. Run hypothesis first, run that sheet first, that cell first, and run the second one. So you see there now it's negative. It is a very small value. It's not negative, it's a very small value. The p-value there is very small because it's raised to power 0.7. So it's a very small value. So that means that is very small, is less than 0.05. So that will mean that 70 is actually different from 56. So we can reject the null hypothesis. I don't know if that concept is home now, Godfrey.
Yes.
Yeah. So that's how, it works in this essence. George, I don't know if you're in the position of talking to confirm if you've understood us.
I'm following.
Okay. Okay. So that is it. That's how we perform one sample t-test. And so you allow me, Godfrey, so that I can proceed with the other types. So we have done the one sample t-test, and for me, in my case, I added another if. You can add the if to build the interpretation. So you can add the interpretation by adding an if statement into it. For me, I hypothesized with 75, and actually it was different. So that led me to reject the null hypothesis, to say that there is a significant difference between the sample mean and the population mean. The hypothesized mean in this case, the sample mean is the hypothesized mean. So we are trying to compare. If this was the population mean, the true population mean, so that means that the sample mean is the mean for the data that we have performed, and now we are comparing it and we are making decision to say that no. So in this case, maybe when I change this to hypothesized mean, and then that will mean that there is a significant difference between the sample mean and the hypothesized mean in that case. So that's how we perform that. And I can proceed to another type of t-test, which is two-sample t-test. So in two-sample t-test, they are of two types. We have paired and unpaired, which we usually use different terms that interchangeably as dependent and independent t-test. Paired is dependent. Independent is unpaired. So steps are the same. The steps for computation are the same. In this case, I'm going to use a sample data to also do the same. So if we already have the background knowledge for one sample t-test, performing the two sample t-test is easy. So we are going to start with the independent sample. We said that in the independent test, we are testing two groups, two different subjects. So the first subject, in this case, we planted, okay, let me say group one was subjected to sunlight. And then group two, these are plants, young plants. So group one was subjected to sunlight and group two was not subjected to sunlight. And we want to know if actually those plants that were subjected to sunlight had a higher growth rate compared to the ones that were not subjected to the sunlight. That's where now we do the independent sample t-test. You can see even in its computation, we are replacing the one sample with int for independent. And then from there, we call the group one and the group two. Group one and group two as our data. So I can just give this to the chat section so that you can also maybe have the same from your end, as I am also going to interpret my output. So yeah, so once you run this, we can be able to get here output. So we can see that the p-value is actually less than 0.05. So when the p-value is less than 0.05, we are going to make a decision out of it. Remember in the above, I added a decision making option using the if statement to help me make a decision. So in this case, maybe if I want also to make a decision, so if the p-value, my p-value here is capital, if p-value, okay, it's small, if p-value, the variable p-value, if p-value is less than 0.05, if p-value is less than 0.05, it helped me to indent. The full column helped me to do the indentation. It's less than 0.05. So what am I going to print to the user? The user should know that we reject the null hypothesis. So what was our null hypothesis? Our null hypothesis maybe in this case was that in this case reject the null hypothesis. So in this case, the null hypothesis was that there is a significant difference. There is a significant difference. There is a significant between the means of the two groups. So in this case, it could be there's a significant difference between the growth rate, the two groups, because they were subjected to different environment of the two plant groups. And now that means that actually the subject, the risk factor in health is usually referred to as the risk factor. So the risk factor is actually significant. Else we indent. Else then we'll be printing. Print. We fail to reject the null hypothesis. We reject the null hypothesis. There is no significant difference between the growth rate of the two groups. There is no significant difference between the growth rate of the two groups Yeah, so just run that again. So I have here my decision based on the p-value that I have. So my decision here is that we reject the null hypothesis. That means that there is a significant difference between the two growth rates, the two growth rate of the two groups, the growth rate of the two groups. I don't know if that is okay also, Godfrey.
Yes. I'm still doing on my side also.
Okay. You are writing the interpretation?
Yes.
Okay. The if statement, okay. So for a data set, it will, if you have a data set, it's a kind of different because you have to subset, you have to categorically state until you achieve the two groups. When you have a data set, you have to partition your data until you reach to the two groups, is where now you can run the analysis. So you're going to look into that. Once you're done, you let me know so that we can be able to proceed to where we import the data. But the data is the same data that we have, but in this case, we want to compare the exam scores between male and female. And we want to know if actually male or female perform better than male. So if there is a difference, we are not looking at difference in terms of gender, and we are not specifically going to check that which side is better than the other. We are just going to check if there's difference. And this is just a sample data. So it is not that it is the reality, because this is a sample data set. So once you have managed to do that, let me know.
I'm okay now.
Okay. So you load the data, we loaded the data. So after loading the data, you subset your data to the columns that you want. So in this case, we want, remember at first you subsetted your data on only exam. So the second one, you have to subset gender, because remember you have two groups. So in gender is where we'll have the two groups, male and female. So for you to get gender, you also get a new variable known as gender. So after doing that, after getting the variable gender and getting this variable, so you have to filter data. You have to filter data. For gender, again, you have to filter data to male and female. So from there, filtering the data, I am going to give male scores as a variable, all the data for people with male gender, for the exam column only. So let me just make this simple by, it depends with how you've named your data set. So you can just make a little adjustments, or you can have the same name. You can just change the name for your data set and just try to see what you can be able to get from your end as we go step by step, so that it can be easier for you to interpret. So from there, we have filtered our data based on the gender, because remember we had group 1, group 2. In this case, we filter our data to get group 1, group 2. Group 1 maybe, for example, gender, and group 2 maybe the female. Group 1 is male, group 2 is female. And then from there, you can now proceed and perform independent t-test. So to perform independent t-test, you just do the same way we did, but in this case, we are assuming equal variances. We are assuming equal variances among our data. Sometimes you can fail to assume your equal variances depending on the scenarios that you have. So in this case, we are assuming equal variances. If you don't want to assume equal variances, you make it false. It will use another type of computation, theoretical computation for that. And then t-test You call the statistic variable, you name another variable known as p-value, and then from the stats, you call a method known as Ttest independent, and then now you give your first group, your second group, and you say it is equal or not. You can also, it's not a must that you have to include it. You can just remove it if you don't want. And then you can give now your output results the same way we just did. And then you also give your interpretation code on how you want to interpret to make your work easier in terms of interpretation. So I'll just have this. So for us to have equal results, we will assume equal variances between our samples. So ensure that your code is well indented, and now you can have your output, and you can interpret from what you see. The p-value for my end is 0.96. So I compare it with the 0.05. And in this case, I have already the interpretation here with me that I will fail to reject the null hypothesis. That will mean that there is no significant difference in the exam scores between males and female. And maybe we perform some no significant difference. Let me just insert here. We have a variable known as male score and female score. So let me just check male score. Maybe we compute the male scores. Let me see. The mean for male score is 56.69. So maybe I compute also the mean for the female score. We are using their means to compare if they are different. So I'm also going to run for female is 56.45. Actually, they are not different. So we fail to reject the null hypothesis. They are actually not different. They are actually not different. Their means are actually not different. I don't know, what are you getting from your end, Godfrey?
I'm still doing it.
Okay.
The second portion.
Okay. So as you do that, maybe Irene, welcome, and you've joined us, and we are covering a very interesting session in hypothesis testing. We are covering hypothesis testing today, and we have just done some analysis here about how we can make decision based on the data that we have. So hypothesis testing, we said it's used for making decision, and we said based on the inferences, of course. We have covered one sample t-test where we have compared the mean performance. This was for example, comparing the height of plants with the hypothesized value height, and to check if the mean for this is different from the hypothesized value. From there, we have been able to import data to Python and be able to check the exam. So for example, we have a hypothesized value that the population mean for the students, okay, maybe with the average mean for the student, we are assuming that is 75. So we want to check if it's actually different from the actual average. So we found out that the average for this, the average was around 56 point something. So to compare that with this hypothesized value, we used one sample t-test and we rejected the null hypothesis. That's why you see here a lot of interpretation and using the if statement here to help us reject the null hypothesis. So maybe you will learn when we will be doing our part of our last analysis, which will be on the paired. And I think from there, you'll get something out of it. And you can now review this later. And in case of any question, you can be able to ask. So what we are doing right now is the unpaired t-test, which we call independent t-test. For example, you want to compare. We started by looking at an example, maybe different plants, maybe in agriculture. You subject two plants in different soil fertility to check if there is an impact on the plant's growth. So you plant the same day, you start measuring their height. After some time, you measure their height. So once you measure the height of these plants that you planted, so you have group one, which was planted in maybe one fertile land, another one in another fertile land, and you want to compare how is the growth rate. Is it different? And then from there, now you do the average. So the plants of the same species, that is. Then you do the average weights. So for you to do that, we use an independent t-test to perform that. So group one was subjected to a different soil fertility. Group two in a different soil fertility. So we want to know if there is a difference in their growth rate. So that's why you see we are performing here t-statistic and the p-value, and then we are making decision out of it. So the session started by introducing these terms you see here. So when you get the recording, you can be able to align with it. So in this case, when we were doing this, we rejected the null hypothesis. This is what you see. We are making the decision using the if statement, because our p-value that we got, which is 0.03, is less than 0.05. 0.05 is the hypothesized, is usually the standard threshold for 95% confidence. So we are 95% confident that the mean for the two groups in terms of height growth is different. So that's what we are looking into. We've looked at that, and we have also imported data now on the exam score, and we want to compare if male and female perform differently in this particular exam. So we want to know if male and female perform differently. Like, we want to know if there is different performance in terms of gender. And actually, from the analysis that we have here, based on the data that we have in this case, is that we fail to reject the null hypothesis. There is no difference between the exam scores between male and female. That means that male and female perform actually on average, they have same mean. And we went forward and computed here independent means, the individual means for male and the individual mean for female, to check if actually what the statement we are making here makes sense. And we can see that 56.69 and 56.45, they are not actually that different. So that's how the hypothesis testing help us to make decision, wise decision, even in businesses, in health, in engineering, in whichever field, in finance, even in research. So we make decision based on whatever we have. I think up to there, you have now a snapshot of what we have covered, Irene.
Yeah, thank you so much.
Okay, yeah, welcome. And we will proceed to pair the t-test. So in pair the t-test is where now you have same group of individuals. Let me just run this. So in pair the t-tests, you have now same groups of individual, like the same subject, and you want to perform something onto them. You want to carry out a treatment. We usually call it a treatment. Subject it to the object or to the subject, and you want to check if there is some change that has happened. For example, you want to compare the student scores before and after going to library. Or let's say you want to compare your immune before taking a particular medicine and after taking a particular medicine, to check if there is difference in terms of the immune system of your body. The same way is like you want to compare your heart rate before doing the exercises and after doing the exercises, to check if how are you healthy? How healthy are you before going to the gym or after going to the gym? You see, these things we can be able to apply them in different fields. It's like checking the soil nutrient, before rain and after rain, checking the soil fertility or the soil content before applying a particular fertilizer and after applying a particular fertilizer, how is the concentration of potassium, how is the concentration of calcium. It depends with which field are you. You can be able to compare, you can be able to perform this, and it will be very important for you to understand how this really work and how you can be able to apply it in data analysis, because the data analysis is a very wide field, so you can be able to apply it in anything that you do. So that's what paired t-test is. And in hypothesis testing, you usually have the null hypothesis. That means that there is always a claim. There is always a claim. So in this case, we are assuming that, for example, these are the head of plants, the same plants. Maybe we gave we before giving them a booster, before giving them a booster for growth, and also after giving them a booster. So the first one is before, the second one is after. So we want to measure their height to check if there is a significant growth, boost growth, if actually giving them a booster was significant. Yeah, so that's the paired aspect. We are using the same individuals, while the independent is where there are different groups. In this case, they are the same groups, but we have a treatment we are performing onto them before and after to check actually if it is significant or not. So that's how we are going to do it. So first of all, we define an array. In this example, I'm using a temporary, generic data that I have, but you can be able to use a data set for you to do that. Of course, you'll have to subset your data that is related, your data that is related, and you can be able to have that. So let me just have this in the chat section. So how to subset your data, we've learned that in the independent t-test. So you can be able to, someone can be able to subset the data. So you can have before and you have after, and you want to check. Now you perform t-test by defining two variables here, the t-stat for t-statistic and p-value for p-value. And then from the stats, which is from SciPy, we get a method called t-test rel. This is for related, meaning paired, matched, related. The other one was int for independent. This one is related. And then we call the before, and then we call the after. And then we print their t-test, the t-statistics, and their p-values. And we look at these values and we compare them with the hypothesized value. And then now we make a decision. So suppose I want to make a decision using the if statement, interpretation using the if statement. So I'll have if the p-value, if the p-value is less than 0.05. 0.05 is a threshold, is a constant. 0.05. Print. We reject the null hypothesis. The null hypothesis. And what was the null hypothesis? That they have null hypothesis was the means are equal. The means are equal. So if it is something like the plants, we say there's no difference in plant growth, and then we close the parentheses, and from there we call the, sorry, we had another opening, so we close like that, and we call the else, statement. We print, we fail to reject the null hypothesis. So in this case, the null hypothesis is that the means are not equal. So when means are not equal, that means what? There is a difference. There's a significant difference. There's no significant difference there. And then there is significant difference in the plant growth. So that's how we do the paired t-test, and we can be able to run and get your interpretation here. So the interpretation here is that we reject the null hypothesis because the means are equal, so no significant difference in the plant growth. So you can see even the p-value is very small than 0.05. So we reject the null hypothesis, the means are equal, so no significant difference. Some additional way of interpretation I've provided here, additional way of interpretation. So you look at the t-statistic, interpreting the results. So we measure the size of the difference relative to the variation in your sample data. So large absolute value indicates a greater difference. So you look at that. P-value indicates the probability of observing your data or something more extreme. So if the p-value is true, lower p-value less than 0.05, you do it. That's a strong evidence against the null hypothesis. So you reject the null hypothesis. Higher p-value, which is greater than 0.05, that means it is a weak evidence against the null hypothesis. So you fail to reject the null hypothesis. In conclusion, hypothesis testing is fundamental in statistical methods used to make inferences about population based on the sample data. Sometimes we use it to make any kind of decision is hypothesis testing. Just know any kind of decision that you make or business related is the hypothesis testing. So you need to see statistics out of it. And the one sample t-test helps determine if a sample mean differ from a known value. For example, there is a process, a business process that your manufacturing process that your organization does, and the producers, let's say that you are manufacturing bulbs, your company manufacturing bulbs, and maybe the lifespan, we want to compare the lifespan of your bulbs that you produce. So you measure the lifespan of 10 bulbs, and actually we have a hypothesized value that your bulbs can only last 1,500 hours. 1,500 hours. And from a sample of 10 bulbs, we want to make a decision based on the sample of 10 bulbs. So we want to compare the hypothesized, the claim value, which is 1,500, with the mean we will get from your sample data. So your sample data can give us 1,000. So in null hypothesis, we are comparing 1,000 and 1,500. Are they different? When you look it with your normal eyes, you may say that they are different. But when you look it with statistical view, they may not be different. So those are some of the things that we make a decision, wise decision based on the insights or data that we have. So up to that point, that marks the analysis of ours today, and I would like Godfrey to give us an overview of what we have learned. So Godfrey, you will share your screen so that we use the remaining minutes to give us the steps that from where we started up to where we've reached from your end, so that we can be able to master it and we can practice on it. Thank you, Godfrey. If you're in position, let me stop sharing.
Thank you. So I've been following. There's a point I stopped working on my document and I started listening to what you are saying. So up to where I've reached, I've learned how to perform. Let me share my screen.
Yeah.
So I've learned how to perform the t-statistics and how to interpret the p-value. As I also learned earlier, I also learned how to clean my data and align, whereby I was working on the Excel, previous Excel, and I have learned how to clean data. So on these, I've learned how to do the okay, how to do the decision part of it using the if and else. So this is something I think I've understood this. Yeah.
So can you just repeat on the part for the independent Ttest, where we had male and female? I think you can just repeat the whole part of that place where we did the using the data set that we had, and then we created variables, gender, and just explain on that
This
part.
point, right? This
Then
point.
we can be able, from that cell 29. Is it 29?
Yes.
Cell,
28.
yes. 28. Okay.
Okay, so from this point, my data was called Excel data. I have assigned it that variable from early, up there. So I chose another variable, gender, to assign the gender variable now from my Excel data, and also the same thing, the exam scores to reference the marks from the Excel data. And from that, now I created another variable now to track my mail scores, whereby I subsetted my Excel data according to gender, which was equals to male, and now I chose my exam variable, the same to female, whereby I chose the gender to be equals to female, and now to take the exam scores. From that, I performed my T statistic and the p-value using the formula stats.ttest, whereby I subsetted my male and female scores. From that point, I printed the T statistic value using the F function. And my interpretation was if the p-value is less than 0.5, we reject the null hypothesis, stating that there's a significant difference. If there's a significant difference in exam scores between males and females, and else, if that's not the case, it would print that will the HO will reject the HO. Will fail to reject the HO. Implying that there is no significant difference in exam scores between males and females. And now after running that, these are the T statistics value and the p-value. So our p-value was greater than 0.05. Hence, we'll fail to reject, being now the else part of the formula. Yes.
Yeah. That's nice, and we appreciate for your input. Yeah, so that's what we have been able to learn today about hypothesis testing. And we are looking forward to learn about analysis of variance in the next class. So please, before the analysis of variance, let's ensure that we've mastered regression analysis and the hypothesis testing. Regression analysis we did on Monday, and this Wednesday about the hypothesis testing. So analysis of variance is also building on top of the hypothesis testing, and I request that over the weekend we can be able to review whatever we've learned. In case you have any question, you need more explanation, you still have an opportunity to mention out so that we can be able to help you proceed. So there's an assignment that I'm going to post in the learning management system, the data set. I'm going to post there so you can be able to perform actually what we have learned today. And that marks the end of our session today.